Good day everyone, I am Ray Grace B. Bernal, and for today's video, we're going to dive into the fundamental concepts of trigonometry. Our focus will be in the 3K learning objectives. First is using correct mathematical notations and terminology. Second is defining and drawing the unit circle while identifying the coordinates of special angles. Third is identifying the 6 trigonometric functions and their value limits based on the unit circle. By the end of this discussion, you should have a strong grasp of these concepts, which are essential for the mastering trigonometry. Let's begin! Using correct mathematical notation and terminology. Mathematical notation is the universal language of mathematics. In trigonometry, precision in the notation ensures clarity in problem solving and communication. Here are some key notations and terminologies. Angle representation. We use degrees and radians to measure angles. For example, 90 degrees is equal pi over 2 radians. Trigonometric functions. This include sine, cosine, tangent, cosecant, secant, and cotangent. Coordinate notation. Ordered pairs x and y represent points on the unit circle. Greek letters, Greek symbols such as theta and alpha commonly denote angles. For example, the sine functions of the angle theta is written as a sine theta using improper notation such as written in sine theta is equal 0.5 without parentheses can lead to confusion. Now, let's move on to the unit circle. Defining and drawing the unit circle and identifying special angle coordinates. The unit circle is a fundamental concept in trigonometry. It is a circle with a radius of 1 unit centered at the origin 0, 0 in the coordinate plane. The equation of the unit circle is x squared plus y squared is equal 1. So now, we will going to learn and understand the unit circle. The radius of the unit circle is always 1. This is our x-axis and our y-axis. Now, the center of the unit circle is 0, which is the starting point. This one is 1 and 0. And this one is 0 and 1. In this side, negative 1 and 0. And here is 0 and negative 1. Now, we will find the value in degrees in every corresponding angles. In the unit circle, we used to start here. This is 0 degrees, and here is 90 degrees. And this one is 180 degrees. This one is 270 degrees. And 360 degrees. The unit circle is divided into 4 quadrants. Each quadrant has a specific pattern of positive and negative values for sine and cosine. The first quadrant, all values are positive. Second quadrant, sine is positive, cosine is negative. Third quadrant, both sine and cosine are negative. Fourth quadrant, cosine is positive, sine is negative. So after having this value, we will now move on to the quadrant 1. Quadrant 1 has 3 angles. These 3 angles are the special angle. This is our 30 degrees. This one is 45 degrees. And this one is 60 degrees. So now we will move on to the second quadrant. In order to get the value of the second quadrant, we need to subtract the 180 degrees to the corresponding degrees in the quadrant 1. 180 degrees minus 30 degrees is equal 150 degrees. This one is 135 degrees and 120 degrees. So now let's move on to the third quadrant. In order to get the value of the third quadrant, we need to add the 180 degrees to 30 degrees. This is 210 degrees. This one is 225 degrees. And the last one is 240 degrees. Now let's move on to the fourth quadrant. To get the value of the fourth quadrant, we need to subtract 360 to the first quadrant 30 degrees. So this is 330 degrees. This one is 315 degrees. And this one is 300 degrees. Before we move on to the value of radian, we must know that this one is 2 pi. This one is pi. And the upper is pi over 2. And 3 pi over 2. In quadrant 1, the value of radian in 30 degrees is pi over 6. And 45 degrees is pi over 4. In 60 degrees, pi over 3. Now, let's move on to the second quadrant. In 120 degrees, this is 2 pi over 3. In 135 degrees, this is 3 pi over 4. In 150 degrees is 5 pi over 6. Now, let's move on to the third quadrant. The value of the radians in 210 degrees is 7 pi over 6. In 225 degrees is 5 pi over 4. And in 240 degrees is 4 pi over 3. Now, let's move on to the fourth quadrant. In 330 degrees is 11 pi over 6. In 315 degrees, 7 pi over 4. And in 300 degrees, it's 5 pi over 3. So after finding the value of degrees and radians, we will now move on to the value of x and y coordinate. The x and y coordinate of the 30 degrees and pi over 6 is equal square root of 3 over 2 and 1 over 2. The x and y coordinates of the 45 degrees and pi over 4 is square root of 2 over 2 and square root of 2 over 2. The x and y coordinates of the 60 degrees and pi over 3 is 1 over 2 and square root of 3 over 2. Now, let's move on in this side. The coordinates of 120 degrees and 2 pi over 3 is square root of negative 1 over 2 and square root of 3 over 2. The coordinates of 135 degrees and 3 pi over 4 is negative square root of 2 over 2 and square root of 2 over 2. The coordinates of 150 degrees and 5 pi over 6 is negative square root of 3 over 2 and 1 over 2. Let's move on in this side. The x and y coordinates of 210 degrees and 7 pi over 6 is negative square root of 3 over 2 and negative 1 over 2. The x and y coordinates of 225 degrees and 5 pi over 4 is negative square root of 2 over 2 and negative square root of 2 over 2. The x and y coordinates of 240 degrees and 4 pi over 3 is negative 1 over 2 and negative square root of 3 over 2. Now, let's move on in this side. The x and y coordinates of 330 degrees and 11 pi over 6 is square root of 3 over 2 and negative 1 over 2. The x and y coordinates of 315 degrees and 7 pi over 4 is square root of 2 over 2 and negative square root of 2 over 2. The x and y coordinates of 300 degrees and 5 pi over 3 is 1 over 2 and negative square root of 3 over 2. Trigonometry is built on 6 fundamental functions: the sine, cosine, tangent, cosecant, secant, and cotangent. To find these functions for the angle data, begin with the right triangle. Each functions relate the angles of two sides of the right triangle. First, let's define the sides of triangle. The hypotenuse is the side opposite the right angle. The hypotenuse is always the longest side of the right triangle. The opposite side is the side opposite to the angle we're interested in data. The adjacent side is the side having both the angles of interest, angles data, and the right angle. The relationship between the trigonometric functions and the sides of triangles are follows. Sine represents the y-coordinate on the unit circle. Sine data is equal opposite over hypotenuse. Cosine represents the x-coordinate on the unit circle. Cosine data is equal adjacent over hypotenuse. Tangent ratio of sine to cosine, tangent is equal opposite over adjacent. Cosecant reciprocal of sine, 1 over sine data is equal hypotenuse over opposite. Secant reciprocal of cosine, 1 over cosine data is equal hypotenuse over adjacent. Cotangent reciprocal of tangent, 1 over cotangent is equal adjacent over opposite.